Good morning, students. Today we are going to see the topic file management from OS subject. So here we're going to solve some basic and very frequent questions which are asked from the file management. So before enter to the file management questions, we have to understand some terms and understand some concept about the file management. So right. So first, what is file? So already we know file means that is a printed document, or it may be a programmatical files, or it may be whatever. So this and all we call it as a file, right? So with this, so these files are usually stored on a secondary storage. So secondary storage may be whatever. Okay, it may be a disk, or it may be a pen drive, it may be whatever. The secondary, apart from the primary storage, the files are stored in a secondary storage. So when we need to access that files from the secondary storage, the time to access and time to get the files are very less. So to get this to access this file very in a lesser time, we need some scheduling operation, right? So whatever the files are which we access from the secondary storage, at roughly it may take several minutes to access, and several minutes to write it. So to avoid all this, the OS will introduce the topic disk scheduling algorithm. So all this for is to use the hardware efficiently. Okay. So for meeting this responsibility, it will have some outside access time and loss this bandwidth. Okay. So first we have to understand what is stick time and what is relational latency. These are the terms which are repeatedly used in your file management. So seek time. So seek time is nothing but on the disk. Okay, but that is a time for disk or to move the edge to the cylinder containing the desired sector. Okay, this is seek time. And rotational latency. Latency is nothing but uh, disk head is there. So many the disk sector will be wherever it is possible. Okay, so time to rotate the disk sector to the disk head is called the rotational latency, right? So seek time and rotational latency is nothing but these are the terms which are used in your file accessing. Okay, here so many types of schedulings are available for better result and better performance, and based on applications we can use any one of this. The basic thing is FCFS, first come first serve. So which file is arrived first, the happening that is it will execute first. So like this FCFS algorithm and SSTF, shortest seek time first. So which is having least amount of number, so it can be accessed first. Then whatever. Okay. So what is scan? Scan is nothing but normal scan operation. So uh, basically scan, what will happen in the scan, when we scan the document or when we scan anything, the scan will move from fourth to back, again back to fourth. So this kind of operation are done in the scan. The same operation will be done in your scan algorithm. Okay. And this C scan and look and C looks, these are the some basic scheduling algorithm. So in this six type of scheduling algorithm, the basic questions which are asked repeatedly from is FCF, first three types. That is FCFS, SSTFS, and scan. Okay. So we're going to see the we're going to solve some problems from these three topics and this a repeated question from this scheduling algorithm. So, right. So, first one, the question is the first, you have to read the question very clearly and understand the question and get the answer. Okay. So, first, the question is consider the system with 100 cylinders. The request to access the cylinders occur in the following sequence. Okay, 100 cylinders is there, but the cylinder or request to access the cylinders occur in the following sequence only: 4, 34, 10. These are the cylinders number. Okay, assuming that it is currently at the cylinder 50. Okay, in this cylinder, okay, 50th cylinder, the it is there. Okay, after accessing 50th file, what is the time taken to satisfy all requests if it is taken 1 millisecond to move from one cylinder to adjacent one? Okay, and shortest seek time first policy is used. So now understand the question. My question is the 100 cylinder will be there and the head is from on the 15th cylinder and so many request stars arrive, that is 4, 34, 10. So which cylinders are served and which one is next? Which is we have to uh, calculate. Okay, so this can be calculated by the SSTF, that is shortest seek time first. Shortest seek time first. This based on this scheduling, we have to analyze the seek time numbers. Okay, so this questions are asked in GATE 2009 and the options given. Okay, so we have to choose the number that is a solution from or from this four. Okay, so first shortest seek time first scheduling. So already we know SSTF. It selects the request with the minimum seek time from the current position. Okay, from current position it will seek select the okay minimum seek time. Okay, so what is my current position? 50. Correct. So first values given in the question, the position from 50. From the 50, the minimum sick time is 30, and after 34 it is 20, and after 20 it is because this 73 and 99 are very large number compared to the 50. Okay, so that's why there's a move, the direction to left direction. 30, 20 after it 19. So 15. Next 10, 7, 6, and 4. Next 2. After serving all the requests to the left side, it will move to the right side. So it will serve 73. Okay. So whenever the question is given, you have to scaling the numbers. So 434, 10, it is not any arranging order. So we have to arrange in a ascending order. That is a 0, next 2, next 4, like this we have to arrange it. Then only we can start from this position. Okay. So from first 50, lowest number 34, after 34, lowest number 20, like this it is. Okay, after scheduling, after confirming all the requests, it will check after what the value is given. Next, it automatically move to the next direction. Okay, so this movement is very important because based on this movement, we're going to calculate the edge movement. Okay, so first 50 minus 34. Next 34 to 20. Next 20 to 90. Like this we have to and write. Okay, 10 to 7, 7 to 6. Next 6 to 4, 4 to 2. from 2 to 73. Okay. So 2 to 73, negative number will be given. That's why I'm writing here 73 to 2. Okay. After this subtraction and after all, add all the values, I'm getting 119. Okay. Time taken. So the given point is time taken to move from one cylinder to the another cylinder. Time is taken for 1 millisecond. Correct. The 1 millisecond need to transfer. So we have to multiply with 119 into 1 millisecond. So my question is 119 millisecond. One one nine millisecond. Right. So next, suppose a disk is as disk as 1 second. Disk as 201 cylinders. Okay, that's read out the next question. Second question here. 201 cylinders from 0 to 100. Okay, so previous we have 100 cylinders. Here 201 cylinders. Okay, so disk arm. Okay, disk arm is at the position 100. Okay, 0 to 100, but the disk arm current position is 100. Okay, there is here disk access request. So what are the requests we got is 30, 85, 90, 100, 105, 110, 135 and 145. These are the some requests. If shortest seek time is being used for scheduling the disk access, the request for cylinder 90 is the serves after servicing dash number of requests. Okay, so say the question is we have some request. Okay, and also we have the current position 100. Okay, the scheduling type is SSTF. Okay, so my question is the cylinder 90 is serviced. Okay, why every cylinder need to service, right? Okay, the cylinder, this particular cylinder is serviced after what the number of after this, each number of requests 90 will served. So this is the question whether it may be one, or it may be two, or whether it may be three. So we have to find out this solution. Okay. So this question are asked in 2014. Okay. Now we have to find out the solution. So this question is very simple only. The current disk arm is cylinder number 900. So already I'm mentioning this one. Second. And my request. So these are my requests, right? So the closest, so shortest take time or shortest take time principle is it will the given request to the shortest number which is closest to 100. Correct. The current position is 100. So with current position 100, 105 is very closest. So after this 105, next closest cylinder is 110. After 110, next closest cylinder is 90. Right. So in all the question we do not write, we do not to find the solution in that is a full solution, full steps. You have to understand. We have to understand the question and logically we thinking and get the solve the answer. So then we have a time to solve the problem is less. Okay. So that's the problem. That's the logical I am playing here. So I do not write anything fully. Just closest to 100, I know that is 100, 100, 105 is closest, and 110 is closest. So after 110, so next 90 is closest. Okay, so 90. So it should be serviced next. So before servicing 90, cylinder 100 and 105 and 110 are serviced. Okay, our current position 100, and this is the second, and this is third. So total number of time, total 3 cylinders serviced before 90. So 19 cylinder, the fourth request. So my answer is 3 cylinders. So this is my answer. Right. Can you get the point here? So now we're going to solve another problem. Okay. So here it is a 2009 question. It is a 1 mark question which is asked in GATE. So very simple one, but you have to understand the basic thing. You can answer this question. The first read out the question. Which of the following disk scheduling strategies is likely to give the best throughput? Best throughput. So what is mean by throughput? Throughput is nothing but total number of work done by in a second. So you can you can done the work 10 number of works in a 1 hour. 20 number of work in a 1 hour. So this is the throughput, right? Okay. So here for this best throughput, nearest cylinder next, that is the SSTF is give the best solution. Okay, by using the SSTF algorithm, we can serve that is scan all the cylinders very nearly to the current service cylinder. So everything is completed very fastly. So that's why my throughput is also best. In terms of my nearest, here the name is the name is hidden from view. That is nearest cylinder. Okay. See, this is the FCFS model. Okay, right. This is the FCFS scheduling, right? The name slightly given. And that is the elevator algorithm. That is the farthest cylinder next. That is the one. Next one. Here, nearest cylinder next means that is the SSTF. Shortest peak time first. So you have to choose this. Answer B is my answer, my solution. Okay, for giving best request for best throughput from all the other scheduling algorithm, SSTF will give the best throughput. Right. So next we're going to see about the fourth problem from the scheduling algorithm. Okay. So first write out the question. Consider this queue, IO blocks and cylinders. So whatever the terms they are used, whether they are given request or IO blocks, whatever it is, but we have to focus on the numbers only. Okay, here what request is 98, 183, 41, 122, 14, 124, 65, 67. Right. The scan scheduling algorithm is used. So my question is scan. Okay. Scan scheduling algorithm used. The added initial position is 53 cylinder. Okay. So now cylinders are numbered from 0 to 199. So totally we have 200 cylinders, and the request is given here. Starting position also given, and my scheduling algorithm is scan. The total head movement. So it is the total number of head movement while servicing this request. So the answer question is here. So here the scan algorithm is given here. So what is scan? So already I'm explaining you scan normal document. When we scan the normal document, the scan light will come move from fourth to back. Again fully scanned. Again it comes to the fourth. Again fourth to back to fourth. Like this scan will happening. The same set of procedures are done here. So it scans all the cylinder of the disk back and forth. So it starts from one end of the disk and move towards the other end to servicing all the requests. Okay, after reaching the other end, it moves to the direction starting and servicing all the requests in between. The same process repeats and repeats. This is called a scan algorithm. Okay, so this is a scan. So same here. So my request is 014. These are my requests. I'm written in the top. Okay, written at the top. My starting position is 53. Right. My starting position is 53. Okay. So from 53, my nearest one is 65. This is fourth to back, right? So 53 to 65. Next 67 and 98. After 122, 124, 183, 199. Fully completed. It's scanned completely. Next, it will move again back to fourth. So fourth, it will service 41 and 14. So all my requests are completed. Okay, here I am going to calculate the request in millisecond. So 65 to 53 minus I am going to write here. Next 67 to 65. Next 98 to 67. 122 to 98. 124 to 122. 183 to 124. 199 to 183. Plus 199 to 41 and 41 to 14. So this difference between this number and get the addition, we have the value 331. 331 end movement. That is a 331 request we have to scan by using this algorithm. Okay, 331 is my answer. Okay, the next question. Suppose the following this request sequence 100 track is given 45 20. So 100 track means they are not written all the 100 track. It means some request only, some amount of request only they are mentioning. Here 45 20 90 and 80 and 70. These are the some requests. Assume that the initial position of read write head is 50. That is here my current position is 50. The additional distance will be transferred by read-write head and the shortest seek time first algorithm is used compared to the scan. So the scan algorithm also we call it as the elevator algorithm. Okay, because the elevator means that is from lowest to upper position. Again upper position to lower position. So that's why the scan and elevator are same. Okay, towards 100 when start execution is dash tracks. Okay, at the starting position we know the shortest SSTF algorithm used. That is two types of algorithm we going to done here. That is here SSTF and scan. Both the algorithm we have to implement and we have to see the difference. So which one is gives so the difference we have to write here. Okay, this question is asked in two times 1990 and 2050. My answer is anyone from here 5, 9, 10, or 11. So next we're going to see the solution SSTF algorithm. So the given file number of tracks is 100. Correct. And the starting position is 50. And write out all the requests. So my starting position of the head movement is 50. So that is here. That is the starting position is 50. So I'll start from 50. Here. So 50. So 50 to shortest one 45. And then again it is 60. Okay. This is SSTM shortest seek time. That is nearest one it is scanned, and after it will move another direction. Okay, and it will scan all the numbers in between. Okay, 60, 70, 80, 90, and after it will uh, go to the another direction. Okay, this is the SSTF way. Okay, so 50 to 45, 5. Okay, 45 to 60, 15. 60 to 70, 10. 70 to 18, 10. 80 to 19, 10. And 90 to 20, 70. 20 to 10, 10. So totally we have 130 movement in SSTF algorithm. So next, scan algorithm. Okay, wow. Scan algorithm. So here the number start is 50. Am I right? 50. And it will move to the backward. That is this first it will move backward. Okay, so it is actually middle position 50. Backward means 60 towards 60. 60, 70, 80, 90, 100. Fully back is over. Next it goes to the fourth. If any request from fourth, it will access. So 45, 20, 10. So you have to write the difference. 60 to 50 and 60 to 70, and all the difference if you write, you can add all the numbers, you get the 135. Therefore, the answer is A. That is, scan algorithm travels for 5 additional tracks. So, scan we have 130, and that is SSTF we have 130, scan we have 135. So, scan will um, 5 additional tracks it is scanned. So my solution is 5. A answer. Option A is my answer. Got it. So here two types of ways. Here we need to calculate two algorithm, SSTF and scan. Here two algorithm I'm implementing and get the difference between two, and I'm selecting this option. Okay. So next the question is, the correct matching for the following pair. Following pair is disk scheduling match with which one? So disk scheduling. So what the all the disk scheduling? Scan algorithm. Disk scheduling, scan, and batch processing. FIF, first one, the batches process in first one algorithm, and time sharing, time of sharing. We have round robin, because in round robin algorithm we have time quantum, equal time quantum we have to given to the all the process. That way time sharing is opt for best opt for round robin. And interrupt processing. Interrupt processing, that is a last in first out. See which one is comes last, it will serve for that is the interruption will be happening here. That's why interrupt processing is last one first out. So my answer is Option C is my answer. Okay. So here, apart from all the option, we have to choose the best one. Okay. So all are relevant to that scheduling uh, properties. So we have to get the properties and nature of any scheduling. It can pair with that process. Okay. So these are some problems which are asked in the scheduling algorithm. Here, so many schedulings are happening here, but repeated. So in these questions, so many are asked from the SSTF and CAN and FCFS. Okay. So apart from this, we have to, it may be rarely the questions will from CLOOK and look and everything. So you have to refer all those. It which will very useful for you. And also the logical problems also we have to apply here. That is here for all the question we do not to spend more time to get the solutions. Okay. By reading the question, if you want if it is needed, then only we have to apply all the steps. If it is not needed, uh, this type of question you have to think logically and get the answer very quickly, because time saving is a very important one. That's why I'm telling like this. So here the question is given. So previously we have seen some of the scheduling algorithm problems we have seen. Here the data is total number of data is given and some standard formula is there. So we are applying the just data on your standard formula, we get the answer. Okay, but we have to, but before we started this type of question, we must understand some of the uh, formula. Okay, a formula, and how to apply this procedure only we need to understand, then we can easily solve this type of question. Okay, this type of questions, this questions are asked from the year 2015. So here, read out the question clearly. Here the question is, consider a disk pack with stick time of 4 milliseconds and rotational speed of 10,000 rotations per minute. That is stick time 4 millisecond. RPM value, that is a rotation per minute is given. So rotation per minute is nothing but it is here. So how much time for each rotation, how much minutes it takes? That is a 10,000 rotation. For one each minute, it takes 10,000. That is a RPM. So it has 6,000 sector per track, and each sector can store 512 bytes of data. So in your disk, there are a number of disk and sectors are given. Okay, each sector can store some amount of data, and how many type amount of sectors they have. These are the formatted data given. So here in this question, they are given 600 sectors. Okay, each sector can store 512 bytes of data. Okay, just understand these three things. So sector, 600 sector, each sector 512 bytes of data. Okay, here consider a file stored in the disk. The file contains 2000 sectors. So some files we need to read out. Okay, that file contains 2000 sectors. Assume that every sector access necessities seek and average rotation latency for accessing each sector is off of the time for one complete rotation. That is off of the time or for each rotation it takes off of the time. The total time needed to read the entire file. Okay. The entire file is given. That is a 2000 sector. So how much time we need? That is we need to redial 2000 sectors. Okay. For the file given and our file amount is given, we need to calculate the total time. So which is also in a milliseconds. Okay. The total time in millisecond way we have to calculate. Okay, the given data, and from this data we have the answer is option A, that is 14,020. 14,020 millisecond is my answer. Okay, so here I'm given here how the way to calculate the answer is I'm given here. Just we follow the steps and we get the answer. Okay. So rotation already we given that is what is RPM and what is sector and what is seek time. Everything we know. That is it is a basics. Okay, this is a basics of this question. The RPM, sectors and data rate. Everything is your basic things. Must understand which is available in our first initially I am given the detailed explanation on this. So this and also we can call it as this are the elements of the or file management or the parameters of the file management. We can call it as. So so in terms of files and field record and uh, in depth we don't discuss on this, just we have to understand what is what at all. Okay. So seek time, that is by given data you just get the data. What are the data given and just we have to collect this one. Okay, here in OS. So what is in your orders? RPM, the RPM value 10,000 rotation is given. Okay, for each cylinders we have we have RPM values 10,000 rotations and the seek time. So seek time is nothing but it is here how much time it needed to complete it in one rotation. That is a seek time. That is seek time is 4 millisecond. In scanning algorithm, that is your FCFS algorithm and FCFS scanning and scan, see, look, and in this type of scanning, we have the term that is a seek time, right? Seek time is nothing but so for each reading a file or for each request, read out the cylinder or anything, we have seek time. So completion time is just okay. That's also they are given sick time. RPM that is or for sick time is 4 milliseconds and RPM value is 10,000. And rotate at very high speed. That is a RPM. That is a rotation of speed. So RPM values differed for each question. That is based on the processor, based on the memory. RPM values that is different, which is start from 5,400 RPM. Okay, from 10,000 RPM. Okay, the RPM value should between this, so because it is a platters, each platters rotate is from this ranges only 5,400 RPM to 10,000 RPM value. So seek time is 4 millisecond. That is a seek time is already we know that is a time taken by the read write reading purpose or writing purpose, a time taken to by the read write hit to reach the desired track from the current position. So from current position to read out and write out the value which is called as a seek time. Okay, and what is a data transfer time? Data transfer times are we are used in our formula. So we must understand what is data transfer time. So data transfer time is nothing but taken to transfer the required amount of data. Okay, so amount of data we need to transfer, right? So how much time needed? That is called a data transfer. It just depends on the rotational speed. So we cannot tell in initial, it's just rotation speed only we can calculate. So here the disk is divided into so many tracks. Okay. So each tracks again divided into so many sectors. Okay. So here the point we need to track is outer track and bigger in the size than the inner track, but they contain the same number of sectors and have equal storage capacity. And here both the values they are given. That is here out. That is the rotation speed and seek time and data transfer rate are given here. So here here 4 millisecond and written here RPM value 10,000. Okay, 1 minute. The question given for 1 minute by we need to calculate in a millisecond. My answer should be in millisecond. That's why I'm just converting minutes to seconds. Milliseconds. Okay, 10,000 to 60 divided by 10,000. I'm getting 6 millisecond. 6 millisecond. So, 6 time 4 millisecond and RPM 6 millisecond. So here rotational latency already they are told off of the time of my rotation I'm here getting the rotational latency. That is the rotational latency is nothing but that is a rotational speed. Okay, off of the time that is a 1 by 2 into 6 millisecond 3 milliseconds. Okay, so these are the data. So main formula is here. Total time includes equal to seek time plus rotational latency plus transfer time. So this adding these three things we get the answer. Seek time, I'm so here the seek time 4 millisecond is there. Rotation latency also there, but we have to find out this one transfer time. So transfer time only we don't know. So we have to calculate this transfer time. So to calculate the transfer time, my formula is transfer rate equal to, first we have to understand transfer time, but the actual transfer time formula is total bytes to be transferred divided by transfer rate. Okay, that is main formula for calculating the transfer time is this one. But anyway, we have to calculate this transfer rate. That's why I'm just written here. First, we have to calculate the transfer rate. Okay, so already I told so many numbers of formula is there. So just we have to understand and apply on it. We get the idea. We get the solution. Correct. So transfer rate bytes and track. So how much bytes we have? 600 bytes. Okay, so here the question is given here 600 sector per track. For each track, here 600 track. That's why bytes and track is 600 into 512. Okay. So in one line, each line they are given 600 tracks and each track 512. Okay, that's why 600 into 512 divided by rotation speed, I'm getting the rate, transfer rate. Okay. So transfer rate is given, we are calculating, then we just apply on this here in this formula. Total bytes, that is the total number of files we need to transfer it 2000. Okay, 2000 into 512 divided by transfer rate is 50,000 into 200. We get the answer 20 milliseconds. Okay, 20 milliseconds. So here, here from my main formula, that is a seek time plus rotation latency. Okay, seek time plus rotation latency what? 4 millisecond and 3 millisecond, 7 millisecond. Okay, here total 200 sectors takes 2000 into 7, 14,000 millisecond. Okay, 14,000 millisecond for 200 sector file. Okay, so not just not completing from this one, because everyone thought this is the final step, but again we have to convert it into what? Total time. That is the total time we didn't calculate. Here we just calculate the one sector. One sector, milliseconds per here calculate. We have to multiply it with the 20. That is a transfer time. Our transfer time is 20. So just that is added with this 20, we get the answer 14,020 millisecond. Okay, so this is the answer of this question. A, option A, 14,020 milliseconds to needed to read the entire file. So the entire file amount is 2000 sectors. Okay, for 2000 sectors, we need this amount of time. That's it. So from this given idea and given data, I'm calculating this answer. So this is the repeated questions. So A 2015 and so many years they are asked, and here everything is here in a descriptive type, and we get just collect the data and apply on your formula, we get the answer. Okay. So next question we're going to see is, so let's read out the question clearly here. Disk request come to disk device for cylinder 10, 22, disk 22, 22, 40, 56, 38. So the disk cylinder request time is given. Okay. So in that order at a time where the disk drive is reading from cylinder 20. So disk request is given. So already this type of questions we are already solved at the first PPT. This is starting itself. We are solving this type of scheduling, that is a scan scheduling and FCFS scheduling, C lookup and lookup scheduling we have solved. So same question, but one changes, one additional changes we have to solve this question. Here, this request come to a driver is given. That is everything is given. Okay. Here, the starting. So from this type of questions, they are given data. Starting cylinder. That is where which is started is given, right? So same here, 20. The started cylinder is 20. The seek time is 6 millisecond per cylinder. Okay. Seek time. Here also they are given the seek time. Okay, for each 111 cylinder, they are requiring 6 millisecond seek time is needed. So compute total seek time if the disk scheduling algorithm is first come first serve basis. So FCFS scheduling method. First come first served. So name itself already we have solved the question scanning algorithm from this type of question, that is FCFS method. So which is nothing but FCFS is nothing but it is a disk is handled and disk is scheduled in which order they are arrived. Okay, in first come first served. So first cylinder which is arrived, that can be um, that can be completed first. Okay, so there is no order in this too. That is and also it is a very simple and very easiest and method is FCFS method. So here the first come first serve method policies. The starting cylinder is 20. So here my given data is 10, 22, 20, 20. That is 46, 38. So first my first cylinder. This is the our first started, that is reader cylinder. So after this 20 cylinder, I'm my next second cylinder is 10. So next second third next cylinder is 22. Third is 20, but already it just surveyed. So that's why again that next apart from the 20 I have 2. Then 40. Then next cylinder 6 plus 38. So this is the order. Okay, this is the order. So here why I'm writing like this means this is the difference between the starting cylinder. So starting cylinder is 20. So the difference between starting cylinder to this one, 20 minus 10, 10. Then 10 minus 22, 12. Okay. That is a 10, 20, 20 minus 22, 2. And 20 minus 36, 18. And 30. This is just a difference between these numbers. I'm writing this one. And not this previous that is a previous scheduling algorithm. We just stop at this step. This difference between this number and just stop. Okay, but here they given the data. Peak time is given. Okay, uh, for one cylinder they are given 6. Okay, for every peak time we have to multiply with the entire value and getting the answer. So got it. So for one cylinder they needed 6 millisecond. So how many cylinders we have? 7 cylinders. So 7 into the 7 cylinders distance into 6, we get 146 into 6, 876 millisecond. So 876 millisecond needed to complete this one. Okay, in FCFS method, my answer is 876 millisecond. So here, this is the questions also asked asked from the GATE exam, and this is also some of the random mistake and by blender mistake here is. So when the students look at this problem here, the given data and algorithm method once they are observed, and they are not look at the tick time is given here. Just they are doing and just write the difference and just write out the answer. But here you must calculate the tick time of every cylinder. I'm getting the answer here. Okay, this is also very simpler method, simpler question. So next the questions we have. So the state of the question clearly. So if the question is if the overhead of formatting a disk. So here the question is given here is the disk. Everything is depends on the disk and sector and how much the RPM needed. So the based on this type of question they are asked frequently. So one file management two portion is there. One is a scanning method. Another one is here this type of basic and formula method. Okay, first off we are seeing the first half of the PPT, and next year we are going to see about the uh, this type of question. Okay, so here the question is if the overhead for the formatting a disk is 96 bytes for 4000 byte sector, then compute the unformatted capacity of the disk for the following parameters. So given parameters is given. So already we know for every disk we have outer diameter and inner diameter and inner track space and surface and sectors. Now how many sectors on each track, how many sectors. So these are the given data. So from this given data, I'm going to calculate, compute the unformatted capacity of the disk. Okay, number of surfaces 8, outer diameter of the disk is 12 centimeter, inner diameter 4 centimeter, inner track space 0.10 millimeter, number of sectors per track is 20. So from this given data, I'm just calculating this unformatted capacity. And next, this is a one of the question. And here, this given data, I have another question. If the disk in A is rotating at 360 RPM, that is rotation per minute is speed is 360 RPM. Determine the effective data transfer rate, which is defined as the number of bytes transferred per second between disk and memory. So we have to calculate here data transfer rate. Okay. So and also the data is transferred between disk and memory, and the RPM is given. So from this point we have to calculate this A and B. So here the solution is given for A solution. That is a first unformatted capacity. The way to calculate the unformatted capacity. So number of tracks. First, we have to calculate the for unformed disk capacity formula. So everything is based on a formula. Formula is number of surfaces. Okay, tracks per surface and sector per track into bytes per sector. Okay, these are the four combinations. We get the answer. Here all everything number of surface and sector per surface and bytes per sector, everything in a given question. Number of surface, inner space, sector per track, everything is given, and only one we have to calculate is track per surface. So for each surface track. So we have to calculate this one. So this is the formula to calculate the track. Number of track equal to outer radius minus inner radius divided by inner track space. Okay, outer radius value is 12 centimeter and minus 4 centimeter divided by 0.10. Okay, 12 minus 4, 8. 8 divided by 8 divided by 2, I'm getting the answer 400. Okay, here I am calculating y means the 2 is 2 radius I am given. No, that's why 2 radius divided by 2, then I am divided with the inner track space. Okay, so I'm getting the answer 400. So after applying this data on this formula, that is the number of surfaces 8. Number of surface 8 and 400 track space is 400. Next, sector per track. Sector per track is 20. Okay, 20 into bytes per sectors. Bytes per sector is here. 4,000. Okay, so main data itself they are given 4,000. So applying multiplying these four things, I'm getting 256 into 10 power 6 B. Okay, bytes. This is 256 into 10 power 6 bytes. But everything we should write in a megabytes. That is a MB order. So 256 MB. Okay, this is the solution for the first one. So first one solution is there, and second one we have to find out the data transfer rate. So the amount to transfer the data in a given time we have to calculate. So in each one given time, how much time, data, that is your 1 MB, 2 MB, kbps have to calculate. Here the solution is capacity of one track equal to sector per track into bytes. Okay, sector per track is 20 and bytes in one sector is 4000 minus 96. We get 20 into 3904 bytes. Okay, here each rotation. Okay, one rotations one minute one rotation, but how many rotation in 1 minute? 360 rotation. Am I correct? 360 rotation in 1 minute. So this we calculate in here 360 rotation. 60 divided by 360, I'm getting answer 1/6. Okay, then complete track is being read. Okay, so in one rotation, complete track is readed by 1/6 second is 20 into 3904 bytes. Okay, this is one rotation to 1/6 seconds. Okay, but we have to calculate not in a 1/6 second. We have to calculate for 1 second. Okay, so 1 second equal to, so 20 into 3904 into 6, I'm getting 4 lakh 60,480 bytes. Okay, anyway, now we have to written in a KB format. Okay, that's 468.480 KB, and the answer is 460.480 kbps. So this is the answer for A solution, A and B question. The formula, if you know, understand the formula, or if you know the formula, you get the answer directly. So by seeing this question, this is a very big question like this, but when we solve this question, we get the answer directly. Okay, just apply on the formula, we get the answer. Okay, here So this file management question, file management question. Here, first we have solved the scanning method. This is so scanning method. Then for given data, we calculate that is the RPM value. We are calculating the sector time and data transfer rate and data transfer time. Everything we are we are find out from this given data. So anyway, that the from the file management question, we are expecting this type of questions only. Okay, not apart from the question, they are no, they didn't ask for anything. So just asking the scheduling types of scheduling, scanning method, uh, that one, and also we are given paragraph or given data. We just find out the latency, speed, everything we have to calculate. But once we have to clearly understand the formula. Okay, please don't by how the formula it will forgot. So we have to understand. Okay, for orders, if we get the orders, we have the track. Okay, one orders we have track, and after this we have some rotations. One will be the how to calculate this data transfer rate by calculating this we have to apply this amount this data we calculating the data transfer amount of time we get. Okay, so this way only we have to understand the formula. So don't buy out the there is no use to buy out the formula. But anyway you have to very strong at that formula. Okay, so these are the some of the questions which are we solved from the GATE previous year questions. Okay, I hope everyone have a clear idea on this topic. Thank you, students. Thank you very much.